Okay, I've been asked about this problem from our homework. This comes from homework number 7, and this is the 6th question in homework number 7. When you click the question help for this one, nothing's available, not even a textbook. So I'll talk through it and hopefully clarify any concerns that you might have. First off, we're given an equation, and this equation is in implicit form since we don't have a single variable isolated. This implicit equation is what's producing this blue curve over here, this curve over here. Normally we can't produce that shape with function notation because it does violate the definition of a function. But the curve is meaningful, and we might need to do some work with it. So the first thing that we need to do is verify that the given point does lie on the curve. And once we do that, then we'll determine the equation of the line tangent to the curve at that point. We won't be able to establish the tangent line equation, the equation of this pinkish purple line here. We can't establish that if this point doesn't actually sit on the blue curve. So that's what we're going to do first. So for question A, let's remind ourselves that this value here, when we have a coordinate, and this coordinate is separate from the equation because of the semicolon. This coordinate says that, or is implying that x is equal to pi squared over 6, and that y is equal to the value pi. So what that means then is that sine of pi plus 6 times pi squared over 6 should be equal to pi squared. And I've established that explanation because, again, this was supposed to be a y value, an x value, and a y squared value according to the description of the equation. So let's see what we get. Ideally, you'll be able to do this without a calculator, but if you use one, I don't think it's the end of the world. Let's remind ourselves of what sine at pi is equal to. Remember, this argument, when placed inside of a sine function, represents an angle measure. And at the angle pi on our unit circle, the y component, since sine is a description of the y component on the unit circle, the y component here is 0. So sine of pi is 0. We have 6 that multiplies by the fraction pi squared over 6. Well, this 6 will cancel with that 6 in the denominator, because this is much like taking this fraction 6 over 1 times pi squared over 6. And that leaves us with pi squared. And of course, on the right-hand side, we've got the y value squared, which is pi squared. And indeed, pi squared equals pi squared. So that's enough to confirm that, yes, part A is true. The coordinate provided is a point on that line. And the question wording in part A looks something like this. The site says when x is equal to pi squared over 6 and y is equal to pi, both sine y plus 6x and y squared are blank. Well, sine of y plus 6x is equal to this y squared, and in both cases, when we simplify either y squared on the right or sine y plus 6x on the left, both of those results end up being pi squared. So I believe that's the answer that they're looking for part A. And I checked that off screen on a different computer, and that is an accepted answer. For part B, we just need to identify the slope-intercept form of the tangent line through that point. So let's start by finding the derivative, and once we've established the derivative, then we can use that to identify our slope. So the original equation was sine y plus, and I'm going to give myself some room here, plus 6x equals y squared. So that now when I apply my derivative notation, the ddx, to all components, we can then find the derivative of each component individually. So the derivative of sine y with respect to x, these two variables differ, So I'll start with the derivative of sine y, which is cosine y. But since this variable differs from this variable, we've got to turn around and multiply by the differential, dy dx. The derivative of 6x does have the same variable as our differential. The expression 6x has the same variable as our differential, so we'll just take the derivative of 6x, which is just 6. And then lastly, for the derivative of y squared in terms of x would be our 2y times our differential dy dx. And we're multiplying by that differential because the variable of the function is different than the variable of our differential. So now we just need to do the math in order to isolate dy dx. So I think what I'll do is I'll just subtract cosine y from both sides of the equation. And now I've got 2y dy dx minus cosine y dy dx. We'll treat dy dx as a common factor. Dy dx multiplies by 2y minus cosine y. And now to isolate dy dx, we'll divide both sides by 2y cosine y. And so we have 6 divided by 2y minus cosine y. So there's our derivative rule. This is going to be helpful for us to find our slope. With the slope and a point, we can then generate the linear equation of the tangent line. Now the slope requires only the y variable in the expression. We don't need the x component at all. So just to double check here, the y value of this point is just pi. So we can now, and I'll switch to a different color to emphasize that we're completing a different component of this problem, is we're going to evaluate dy dx at a y value of pi. If we needed to include both x and y, we would say x equals and then write the number, or we can use a notation that I've used in the past and simply write the coordinate, which is pi squared over 6 comma pi. We don't need the pi squared over 6 because the expression doesn't require it. Only y values are needed. So we have 6 divided by 2 times pi minus cosine of pi. And if we evaluate, we've got 6 in the numerator, 2 pi in the denominator, minus, and then off to the side I'm thinking about my unit circle at the position pi. Cosine evaluated there. Well, cosine is asking about the x-coordinate at this position, and the x-coordinate there is -1. So we see that the slope of this line is 6 divided by 2 pi plus 1. Now that seems strange to say that the slope is equal to 6 over 2 pi plus 1, but I'm going to leave the slope just as it is. I'm not going to turn this into a decimal or any other fraction because the instructions do say to type an exact answer using pi as needed. So no decimals or no rounding is going to be permitted here. So let's see what happens next. And by the way, the calculus component of this problem was over all the way back here. Everything beyond this point, finding the derivative, became an algebra problem. So when we substituted into the derivative, and now that we're substituting into our point slope formula, this is all just a challenging algebra problem at this point. The calculus is done. So here again, we have a y value of pi. We have a slope, which is a weird slope, but a slope nonetheless of 6 over 2 pi plus 1, and an x-coordinate of pi squared over 6. So what I like to do is just clear the parentheses on the left side if I can in this first step, and then try to distribute in to the parentheses on this right side. So we're going to end up with 6 over 2 pi plus 1 times x minus, Now, the 6 in this numerator is going to factor out or cancel the 6 in this denominator, and we'll be left with pi squared on the top and 2 pi plus 1 in the bottom. And now the last thing to do is to add pi to both sides of the equation. Y is equal to 6 over 2 pi plus 1x minus pi squared over 2 pi plus 1 plus pi. Now, MathXL is only giving us 2 boxes to enter results in, and I'm curious what's going to happen if we try to enter this value here in front of the x as our slope, and then this value here as our y-intercept. I don't know if it'll accept it, but I'm going to try that right now. And it worked. So I got the okay. It said excellent to that solution. One thing I was very mindful of while reporting this was that I did include the negative sign in front of this fraction, and I made sure that the fraction separated this pi squared and 2 pi plus 1 in its entirety, so the fraction bar did extend all the way across. And as long as you're careful with that, I think the process would be the same as any other problem that's written like this. We had to verify the point by substituting in x and y. So back at the beginning, we simply substituted in our x and our y value to make sure that both sides of the equation are equivalent. And then after establishing our slope formula using a bit of calculus and implicit differentiation, we were then able to determine our slope and use the point slope formula to simplify. And out of curiosity, I did calculate the decimal equivalent of each of these fractions with the pi values. So it looks like there's a slope of approximately 1 and a y-intercept of pretty close to 2. And if I were to compare that to the graph that we had up here, I think that looks pretty good. There is a y-intercept of just about 2. This looks like it could be 1.78 to me. And then the slope, rise and run, certainly is pretty close to a 1 over 1 rise over run. So I'm guessing that this graph was drawn to scale and accurately, so you might count on that. On your MathXL question, you can use that as a guide or as a hint, if you will, whether or not you're doing your work correctly. But I do believe that the process that we've established here should be good for you as well. Hope this helps. If you've got further questions, please let me know. Thanks for watching.